Hello guys, welcome to Crown Smart. In this video we want to show that the following functions are bijective functions. Okay, we want to check if the following functions are bijective. Now from our previous video we know that the first question where we have f of x is equal to what? 2x plus 3. We know from our previous video that this is 1 to 1. Okay, this function is a 1-to-1 function because for it to be a 1-to-1 function, f of x must be equal to f of y, implying that x is equal to what? Y. So this is 1-to-1, and the range for this is all real numbers, which is corresponding to that of the codomain. So this function is what? A bijective function, because a bijective function is a function that is 1-to-1 and is what? Onto. So when a function is 1-to-1 and is onto, it's called a what? A bijective function. So this function is 1-to-1 and is onto, so it's what? It's a bijective function. Now the next question we have that f of x is these two questions. Let's look at these two questions. Now these two questions are quadratic functions, and we know that quadratic function in general, we have already shown that quadratic function in general are not 1-to-1. So since quadratic function are not 1-to-1, there is no point checking if it is what? Onto, because for it to be a bijective function it must be 1-to-1 and it must be what? Onto. So since it's not 1-to-1, therefore it is not a what? A bijective function. Now the next question now is let f map this to R. Okay, now f of x is defined as ln of this. Now from my previous video we know that this function is an onto function because the range is all real numbers, which is the same as the codomain. Now let's see if this function is 1-to-1. Now by definition of 1-to-1, it means that f of x must be equal to what? F of y, meaning that ln x minus y must be equal to what? Ln x minus 1 is equal to ln y minus 1. Now if you do exponential of both sides, we are going to have exponential of ln x minus 1 is equal to exponential of ln y minus 1. We are going to have the exponential remove this, so we are left with x minus 1 is equal to what? Y minus 1. So if you add 1 to both sides, we are going to have that x is equal to y. So this is a what? A 1-to-1 function. So this is a 1-to-1 function and an onto function. Therefore this function is what? A bijective what? Function. Now the next question here we have that we have the function f mapping from this to R. Now observe that f of x equal to this is a 1-to-1 function. Okay, let's say we're having x minus 1 is equal to the square root of y minus 1. Now it's a 1-to-1 function. Now if you square both sides, you're having x minus 1 is equal to what? Y minus 1. Now if you add 1 to both sides, you have x is equal to what? Y. If you add 1 to both sides, that is, you are doing x minus 1 plus 1 is equal to y minus 1 plus 1. As you are adding 1 to both sides, so this will be x is equal to what? Y, because minus 1 plus 1 will give us what? 0. Now we have shown that this function is 1-to-1. Is the function onto. Now from our previous video we know that this function is not onto because the range of this function is 0 to what? Infinity. The range is from 0 to what? Infinity, which is not the same thing as the what? The codomain. Remember, whenever f is mapping this to this is the domain, this is the codomain. So since the codomain is not equal to the range, therefore it is not what? Onto. So therefore in general this function is not what? A bijective function for this question. Now the next one we have here is the function is mapping from this to this. Now observe that the range of this function is equal to the codomain of this function. Okay, because f is mapping this domain to this codomain, and the range and f is defined as this. So the range of this function is actually this. So since the range of function is actually equal to the codomain, therefore the function is what? Onto. Now what is this function 1-to-1? We have shown here that the function is what? 1-to-1. Therefore this function is a bijective function if it is defined as this. So if the function f is mapping this to this, therefore, and the range of this function is equal to the codomain of this function, therefore this function is what? A bijective function in this case. So for this question this function is a bijective function, but for this question is not what? A bijective what? Function. Okay, thank you very much. And our next video we are going to talk about the inverse of a function. Remember, for a function to have an inverse, it must be what? A bijective function. So we are going to discuss this in our next video. Thank you very much, and please do not forget to subscribe. Thank you.